Hello everyone, welcome to another video on AI update side. So in this video we'll discuss about another OCR model that is from Nanonets, and this is the state of the art image to markdown OCR model that goes far beyond the traditional text extraction. So as you may know, the traditional text extraction model basically works on the plain text or sometimes on the page numbers or some basic numbers as well. But this OCR model is able to extract or get the context of the table, equations, images, plots, watermarks, checkbox, and many more things. So, and other than that, like basic text to image to text models are mainly focused on the plain text, and that they are able to extract from the images, but they basically fails on the watermark signatures, page numbers, and other visual or complex visual things like tables or checkbox. So they basically majorly fail on these areas. But this model is able to get or recognize the latex equations, the image description, and signature detection and extraction, watermark extraction, and the smart checkbox handling, and the complex table extraction. So this model basically available as a open source on Hugging Face. I can show you on the page. So this is the page of Hugging Face, as they have mentioned here as well. This model is capable to recognize the latex equations, intelligent image description, signature detection, watermark extraction, smart checkbox handling, and complex table extraction. So the code is present here. It is, you can take this model uh, path, and from the transformer you can get here, and you can deploy that model in your VM and utilize it. So basically it overcomes so the traditional OCR models capabilities. So like sometimes we need to use multiple OCR models, like for latex equation we need to use different OCR model, for table we need to use different OCR model, and for image to caption we need to use different OCR model. But this model is capable to extract everything into this one model. So this model is based on the Quen 2.5 VLM, and let me show you the some of the examples. So this is the latex equation recognition example. As you can see here, there in this image there are some formulas present here, this one, and this model is able to get this formula. So this is the model output, and this is the row output. As you can see here, let me take one formula and show you. Let me take this formula. This formula is basically based on top of the sky math, and as you can see here, it is seems to be correct, almost correct, I can see that. And let us match from here input, and this is the one, rxyb log pi r, rxyb log pi r versus beta z. It took this one, but I don't know why. I believe this that one is this is a full equation, or this is just a tag, I believe, because the dollar is also a tag. As you can see here, dollar is also a thing, like so that you can know this is the sky math formula, and this is a tag 4. This is a, maybe this is the fourth formula, this is the fifth formula, like this. And it also supports the intelligent image description, as I can show you the example here. This is the image page research paper image that they have used, this one, and let us see the output now. So basically it will bound this image output under the image bracket. Let me show you here the image tag, like same like we used in the HTML. And here it completes. So other than that, it supports the signature detection as well. It will bound that signature into the signature tag. As you can see here, this is the input image and this is the signature. and this is the output image, and this is how it bounds that signature into the signature tag. And let me show you the output, raw output from the model. This is the raw output from the model, and this is the signature. And let me show you the another example of for the watermark. This will also bound under the watermark tag, and this is the image. So should you may notice the placement of this paid watermark, and here as well in the output the placement is same. As you can see here, watermark, paid watermark is present here in the table itself. Okay, I don't know why I'm not able to scroll here. Yeah. So as you can see here, the output watermark paid as a watermark, then the closer watermark. Yeah. So now we will see about the checkbox handling. So as you can see here in the example, there are some checkbox, and some are checked, some are not checked. And let us see the output now. And output as well, you can see some are checked and some are not checked. And the raw output, let us see this one is checked, this one is not checked. And based on that, you can handle that in your code. Based on this output, you can handle that in your code. And now we'll see the complex table extraction. The table will be in the normal HTML table, like the normal we see the normal HTML table. And this is the research paper of Quinn 2.5 VL, I believe. And this is the output, and this is the raw output. As you can see here, table tr td tr close td td close, then again tr td. Yeah, in normal HTML tag. So basically all the LLMs are able to get the normal HTML tags, so it is fine. In the training details they have provided, like they have trained this model on synthetic data as well as the manual annotated data. And so they have used almost 250,000 pages of the research paper, financial documents, legal documents, healthcare documents, text forms, recipes and invoices. And that they contain the images, plots, equations, signature, watermark, checkbox, complex tables as well. And as I mentioned, they have trained on the synthetic and manually annotated data. So first, they have trained their base model that they have used Quen 2.5 VL3B. So they have trained the synthetic data first, and then they have fine tuned with the manual annotated data, this VLM. So to get the improved performance and on the document specific optical character recognition. So there are some limitation as well. They have not trained on the handwritten text, and sometimes models suffer from the hallucination. And their use cases are, you can use this model on the academic and research paper, legal and financial papers or documents, healthcare and pharma documents, and corporate and enterprise documents you can use here. So basically, in the world moving towards the LLM driven automation, unstructured data is still the biggest bottleneck, and this Nanonets OCR-s bridge that gap, transforming the messy document into the clean and structured, context rich markdown that modern AI application demand. So you can use this model from the Hugging Face that I already showed you here, and you can load that in your VM and use that. So this is it, and we will see tomorrow with some exciting new AI updates or some other tutorials. Okay, thank you. This is it. Bye bye.